Well, thanks very much for inviting me along to speak, Simon, and thanks for everyone to kind of turning up and listen to me drone on. And thanks also to DLA Piper for hosting the event offices. Tonight I'm going to talk about the current internet infrastructure. So Simon was saying this centralized infrastructure, and really looking into the stuff that powers all the apps and devices that we've become so used to using, and how they affect and govern the relationship with our own data and the companies that provide services. I'm going to look at some of the problems with internet architecture as well. Hopefully it's not as boring as it sounds, and highlight some different approaches that both the company I work for, MAIDSafe, and others are taking. So I hope you enjoy the talk. So in late October, just a month ago, several of the sites here, The Guardian, CNN, Netflix, Spotify, and others, went offline. And the reason that they went offline was not a problem with the sites themselves. What happened was there was a botnet, which is a networked amount of devices that were controlled by a piece of malicious software that effectively attacked a company called DIN. So what they did was a distributed denial of service attack, which is a lot of words, a DDoS attack. So what they effectively did is go after the servers and make so many requests in those servers that they're unable to process the data, and they literally collapse under the amount of requests, meaning that they're unable to serve legitimate requests for data. Now this was relevant to, and the reason I bring this up and it's relevant to this group, is this attack was bringing together 100,000 IoT devices. So these were digital video recorders and mostly digital cameras that were affected with this Mariah botnet. These 100,000 devices made all these requests onto a company called DIN. Now DIN is a New Hampshire-based DNS provider. So DNS is domain name service, and they effectively route all our traffic to the correct points. So if you type in spotify.com, companies like DIN make sure that you get routed to that specific page. So when this company DIN was attacked and targeted, all of these sites were taken down as a result. And this is partly because of the fact that data right now is centralized on data centers and servers. Now, data is also inherently insecure, and it doesn't need me to tell you that. I think we're almost desensitized to the amount of attacks and stuff that we see today. I think people like Sony Pictures is one, TalkTalk, internet service provider, Target, Tesco was recently hit as well. And these attacks are very, very expensive, and there's a lot of data being stolen. So about 3.6 billion records have been stolen from January 2013 to January this year. Now those records can be anything from passwords, user IDs, credit cards, or if you're a celebrity, your iCloud account gets hacked on a daily basis and your picture's put online. So everything's getting stolen. And they're expensive. IBM think that these hacks cost about $154 per record for the companies that are targeted. And that information, those costs are coming from losing customers and making it harder for those companies to acquire new customers. Now, if you do simple maths of multiplying the number of stolen records by that cost, you've got a bill of over $500 billion in the last 3 years. So it's a significant problem. And we really don't have a solution for it at the moment. We're trying to apply, in my opinion, at least kind of patchwork, trying to put plasters over this problem. But fundamentally, the networks that we're using are not secure. And this is also affecting consumer confidence as well. So you can see from this chart here, and this was a large study taken about a year ago in Europe, and it's about 24,000 respondents, and 50% of those cite becoming a victim of fraud as their biggest concern, and 44% online data being used for fraudulent purposes. I would suspect if you did that same survey again, you would probably see the numbers are even higher than that. Now, this is not only, data breaches don't only happen to large businesses, although they are the ones that make the headlines. We're seeing in the UK, about 74% of SMEs are reporting a breach every year. So it's really affecting us all. And just when I've not beaten data centers down quite enough, other problems with them as well. in my view, they're extremely expensive. So Google has about 15 data centers worldwide, and when they were built, each cost about $1 billion to build. So if you look back to 2007, Google's a public company, so a lot of this information is available online. So back in 2007, their bill for data centers was about $2.4 billion, which is a pretty hefty bill already. Fast forward to 2015, and that bill had risen to $11 billion. And if you then add on the first quarter of 2016, you get 5 quarters costing $13 billion, so extremely expensive. And interestingly, data centers actually use 3% of the entire world's electricity, so it's a real drain on our resources. And even small data centers are expensive. By small, I could mean something like 50 to 400 servers. Excluding the construction of that building, just the acquisition of the racks and the servers, etc., would cost about $600,000 to $1 million a year to put together and maintain. So extremely expensive. So Houston, we have a problem. So centralized services are obviously very vulnerable to attack. And these problems are only set to continue. So if you look at IoT again and the number of connected devices, so Gartner tells us that we're going to have about 6.5 billion connected devices by the end of this year. I don't know how we check that, but that's what they tell us. Now, by the end of 2020, we're looking at about 21 billion devices. So this problem is not going away. And I think one of the major issues I personally have is that we don't control any of this data. So Simon was kind of talking about it at the start as well. It's, in many cases, this data, we see it as ours, and it is ours because we produce the content. But the gatekeepers allow us to access it. So anytime your access to your data, whether it's in Dropbox or Google or whatever, can be revoked. I don't know if any of you guys saw in the news, Mark Zuckerberg, his Facebook account was deleted. And obviously that was a mistake. And I'm not saying that goes on all the time, but it's something that you don't have that power as users. And it's that old cliche, you're not a user of that service, you're the product itself. And these companies make money by selling your data and access to you to advertisers. And finally, also, IoT devices are insecure. As the attack I talked about at the start with DIN, I think a lot of energy has gone into connecting these devices and making them do really clever things. I was surprised to learn that the guy, Paul Brody, who's going to speak later, is involved in a project called Adept, and some of the stuff he'll talk about is really, really incredible. But I don't know that much thought has been given to the security of those devices. So these are issues as well. Again, as Simon was talking about, this is a simplified model, of course, because the internet's a bit more complex than this, but just so everyone understands what I'm meaning by centralized. As we can see here on the left, a representation of the existing internet where multiple nodes access single servers, single points of failure, as we've seen. And then lots of different decentralized models. There's distributed, there's decentralized, there's hybrid models as well. The one I've focused on here is the company I work for, MAIDSafe, is building something called the SAFE network, which I'll look at. And this is a classic peer-to-peer model. So all of these nodes or devices or computers on the network all have equal authority in the network, and there's no central point of control. So that's what we're talking about when we mean decentralization. And I mean, this paradigm is certainly not MAIDSafe. The decentralization is probably the most logical, I would say, model, and something that actually is, we're not reinventing anything here. It's actually going back to the way the internet was. So in the early 70s, I think, ARPANET, which was one of the kind of an earlier version of the internet, if you like, was decentralized, and just as it became more commercial, it became centralized. So what we're really doing here is going back to the roots, I would say, of the internet. You've got other things like BitTorrent, which is a decentralized technology as well. I'm sure many in the room have heard of BitTorrent or even use it to pirate movies, although you might not admit it. And that's really, really well used. So you've got about 15 to 30 million concurrent users, and about 300 million people a month use that service. So decentralized technology has been around a long time, and it is well in use. So as I say, MAIDSafe is a company based in sunny Troon, and we are building the secure access for everyone, or SAFE network, And what we are doing is we are removing data centers and servers from the management of our data and replacing them with the spare computing resources of all the users on the network. Now, people often ask, is there enough space that we have to store all of our data? There's lots of it. But if you look, they reckon there's about 1 billion connected devices. And by devices, I mean laptops and desktops. And if we assume, probably quite prudently, that there's about 50 gig of available storage on each of those devices. Now, I've got a laptop, I probably have a few hundred gig free on it. And if we all gave those into this network, you would have about 500,000 petabytes of data. Now, that's a hard number to get your head around. A petabyte is 1 million gigabytes, and an HD film is about a gig. So that is an awful lot of information. To put this in context, Google, I think it was about 4 years ago, they were thought to have about 8,000 petabytes of data to serve YouTube, mail, and all the applications that they have. There'll be way more than that now for sure, but just to show, 500,000 petabytes is an awful lot. So on this network that we are building this infrastructure. The intention is that this will replace all web services. And so we will build almost like the train tracks, if you will, and we'll have application developers hopefully building applications on top that end users will use. So this is a data and communications network. So we'll be able to put things like YouTube, Dropbox, any type of app that you can build today. And at the moment, what's possible in this network, and I'll talk a little bit about where we are right now, but it's possible to store data, host websites, email, do Skype type chats through WebRTC. So this stuff is available today, although be it in fairly early form, I must say. So as people are storing data on this network, it's always encrypted. So a big thing that MAIDSafe are focused on is security and privacy. So there's lots of decentralized networks out there. It's bewildering to know how they're all different from one another. You get things like IPFS, you'll hear Ethereum and others, and sometimes it's very difficult to tell them apart because even the language that they use is very confusing. I mean, I go into some of the sites, sometimes even look at our own stuff and I think, I don't even know what we mean with that. So it's very difficult because they're almost coming up with the language on the fly. But on the Safe network at least, whenever data is uploaded or saved onto the network, it is automatically broken down into chunks, randomized and encrypted and stored on all the different computers across the network. So security is a real focus, and only the correct credentials can reconstitute those files and bring them back. Now, each node in the network, so that could be a computer at home, for you guys, so you could just download our software and contribute to this network. And your computer at home would perform multiple different functions on the network, sometimes at the same time. So you could maybe store data at home, you could route traffic to a piece of data, you could decide whether someone else has access to a piece of data. And you don't ever do this, your node doesn't have the ability to do this alone. It forms consensus with lots of other nodes that make decisions. And the reason that we need to do that is because there's no centralized point of control. So we're looking for all of your computers to use the algorithms of the network to make decisions. And we don't ask that people leave their resources for free on the network. So the network will pay you. So this is not something that's enabled yet, but there's a cryptocurrency on the network called SafeCoin, which is kind of akin to Bitcoin in some respects. So it's like digital money for those of you not familiar with it. And this is a proxy of SafeCoin is available today and traded on exchanges right now. So they're worth about 7 cents each, and there's about $200,000 a day is traded of these coins, and we've not launched the network yet. So as you store data for other people, and that data is retrieved from your computer at home that's potentially doing nothing, sitting in a corner, all you need to do is turn it on. You would be paid by the network, not by the company MAIDSafe, but by the network, these safe coins. And as users, you could then take those safe coins and either use them for other services on the network or take them to an online exchange and convert them into cash. So you could actually have the untapped resource you have at home earning money for you. Now, with MAIDSafe, there's no blockchain. So so which is an interesting. And obviously it's this public append-only ledger that really keeps track of and keeps everyone honest on the network. And this is also used for consensus as well. Now, MAIDSafe don't have a blockchain, so we actually don't know all the owners of a coin. All we have is the current owner and the previous owner of a coin. So you should think of it in some way as digital cash. So if you went to a newsagent and bought a paper, all you could really say, the newsagent could say, well, you paid me that, so I knew you were the previous owner and I'm now the current owner. And in doing that, not having this blockchain, it's not suitable for every type of use case. So if you're a bank, that's not a particularly suitable way of running things. You would want this ledger. But for people serving data, it removes all these scaling issues that you get with Bitcoin. And you could also imagine that these computers I'm talking about at home, these could also be IoT devices. So we could start to have smart homes, and I'm thinking way into the future here. This is not something that's going to happen tomorrow, but you could have all these devices basically connected by the Safe network. And I think actually as we move forward, what we'll see lots and lots of different types of networks for different functions. You'll have blockchains for financial networks, maybe things like the Safe network for data, and lots of other IPFS for data availability and things like that. Now, in terms of where we are right now, I often get excited and talk about this as if it exists today, and people always kind of say, well, it's not, and a lot of it's theory, and that is correct to say that. So what we have today is a few hundred nodes running in a data center, ironically enough. And the reason we're running a data center is because we need these nodes to be online and of a reasonable spec. So we have enabled users to run their computers from home, but what we found was typically the nodes were not fast enough to maintain the performance of the network. So people maybe had terrible internet connections. We found some crazy people trying to run 2,000 nodes on one machine and stuff like that, the types of things users do. And that adversely affected the performance. So we're making some fixes there to account for that, and then we'll release nodes running from home. But this technology, much of it exists today, and we're just kind of bringing it all together now. In terms of trying to refer this back then to all the kind of miserable points I made at the start and depressed everyone, we believe that the network is resilient to many of the problems that we have today. I'm not going to say it's going to fix everything, and we'll need to partner with people to fix some of these, but we do think it will fix a lot of these problems. In terms of denial of service attacks, data on this network is served from multiple points, multiple nodes, not just one. So there's no single point to target. The inventor of the Safe network, David, often says it's like trying to stop this is like trying to poke a hole in the sea. As soon as you poke it in, you're surrounded with water again. And you can think about nodes in the same respect. If a node is taken offline, another one will come in and take its place. And that's true of many decentralized systems. And we have a thing called opportunistic caching, which I'll not go into in much detail, but basically, as data becomes popular in the network, more copies are created. And also, we don't use DNS, so that removes the possibility of denial of service attacks that we spoke to at the start. We've also got a focus on security, as I mentioned, so data is always encrypted. Quite often when we see data stolen from companies and people rifle through and take credit cards or publish names online and things, if that data was encrypted, they couldn't do anything with it. So encryption is very, very important, obviously. And the data on our network is encrypted client-side, which means on the computer. So none of this information exists on the network. So if you enter a password, it doesn't exist on the network. It can't be stolen from the network. Only you know what it is. So it would require someone to come and beat you with a hammer to tell you what your password is, or they could have a keylogger. So endpoint security is still an issue, but it's client-side encrypted. So we don't know the passwords on the network. We don't even know who our users are, where they're based. We don't even know what they're looking at, and we can only make approximations about how many we have on the network, which is a very strange concept when you think about it. A nightmare for marketers. You know, how is the company doing? How many users do you have? We generally don't know. But that's the price of security, I would say. We've got built-in privacy and anonymity. So node IDs are assigned at random by the network. And IP addresses, so the IP address is like your online postcode, if you like, which identifies you. That is scrubbed on first hop. So as soon as you come onto the network, we don't know who you are. Scale, it scales very well, or it will do once it starts to scale, around, and so the network is scaling around its users. So as people download the software and start running it, the network will increase in size. And obviously, for whatever reason they decide to take it off, it will decrease. Quite a different model when you look at something like Google, who have to plan about 5 years in advance for putting a data center in. They have to get planning, they have to get builders in. Is there a stream nearby to cool the data centers? And then they have to hope that the users come. And then once they have all that, the horrendous costs kick in. This is a network that is using untapped resource, or will hopefully be using this untapped resource. And it's also low cost, so we don't know, because the network is still not fully out in the wild, we don't know costs. Logic would suggest to you it should be significantly cheaper than what we have today because it's unused computing resource. And what users are really doing is paying for their electricity. In this country, we're fortunate enough to have mostly unlimited data on the internet. Countries like America, it's not like that. But for us here in a lot of Europe, the cost will be extremely low. And you could even lower it further by having low energy devices. So you can have single board computers like Raspberry Pis, and you can just plug it in, leave it in all the time, and just have it running away in the corner, potentially earning you money, which is an interesting concept. So in conclusion, hopefully I'm kind of running on time, I'm not sure, but centralized networks can deliver really high performance, but they are prone to attack. And decentralization is, like I say, is not just the domain of MAIDSafe. I was going to talk a bit about Adept, but I'm not going to do that now because Paul Proddy is going to speak about it, and he was one of the creators of it. And I don't want to say the wrong thing and screw it up, and he'll tell you about it anyway. So that's really, really interesting. But there's big companies getting involved in decentralization as well. And for people who are aware of Bitcoin, you'll know the massive amount of investment that is going in there now. So there's been over $1 billion worth of investment. So even forget the stuff like all the financial institutions and banks using it. In actual smaller companies like MAIDSafe, we would be kind of termed as a blockchain or Bitcoin 2.0 type company. There is a lot of investment going in. There is something here for sure. Whether it's, I hope it's MAIDSafe that will be one that breaks through, but the reality is it will be hopefully a few of us that will break through, because these changes definitely require to be made. And I think what we're seeing here, just to kind of wrap up, is that the technology that we're seeing is really technology, not just infrastructure, is that we're seeing decentralization is taking hold across all our lives. So if we look at things like education, Udacity and Code Academy and all these sites online were unimaginable a few years ago. And even look at things like 3D printing. Everything is, technology is allowing us to become more decentralized. We don't even need to go into the office now to work, we can work at home. As a company, MAIDSafe have about 18 staff. I was just saying to the guys earlier, 18 months ago, we had 20 of those guys, or 18 of those guys based in Troon. We've now got 7, and the rest are based in India, Brazil, Prague, all across the world. And so I think decentralization is really taking hold, and technology, I think, is the main driver. So thanks very much for listening. Thank you.